Oh, it's me again. Yeah, thank you everyone still sitting here. And actually, this work is our team's work, and I'm just a representative to present this study. This study is focused on urban thermal environment and surface energy balance. By using the master of a scaled outdoor experiment, yes, this is our own platform. And as I mentioned in last presentation, urban energy balance can explain the mechanism of urban heat island. However, the urban energy balance is also affected by many factors, including meteorological condition and building morphology and urban greening and anthropogenic heat source. And but the coupling mechanism of this factor is complicated and it cannot be obtained completely in a real city because in real city we cannot describe anthropogenic heat accurately and we cannot measure heat storage directly so as a result, there is a problem about the surface energy balance observation. That is, its uncertainty is large. However, in the scale outdoor platform, we can control the anthropogenic heat, and we usually neglected it and the heat storage can be measured directly, and the net advective heat can be set as zero because the underlying surface is homogeneous. This picture is a cosmos conducted by Kanda in Japan. So we also established our own scale outdoor platform. We call it so much. And so much that is mean scale outdoor measurement of urban climate and health. It is located in suburban of Guangzhou, and this picture is shown for 3D urban model. And we can also change the building layout to imitate the 2D street canyon. We use it to analyze the surface energy balance and the outdoor thermal environment in different building aspect ratio. The first aspect ratio of 0 point is wide canyon, and the aspect ratio of 2 is deep canyon and both building heights are 0.5 meter. In the 3D urban model, this is his building and the instrument layout. We also use AD Calaris system to measure the turbulent flux, and we located it on the center of the study site and the measure height is 2 times of the building blocks height. And we also measured the surface temperature in roof, in walls, and on ground. And we also measured air temperature inside the building block and outside the building block. And the temperature measurement were placed in different heights and were measured by thermocouple and eye button. This is building and instrument layout for 2D street canyon. Same to 3D urban models, we also measured turbulent flux and we measured air temperature and the surface temperature. And we use a master called ESTM master to calculate heat storage. This master is based on overall surface temperature measurement. And now I'll show some results. First is the daily temperature in different building units. water model and hollow model. Water model means we filled with water inside the building model, and the hollow model is empty. And we found a critical parameter influencing the surface temperature, that is solar radiation. So you can see the temperature and the eastern and west were peak at a different time. And for the water model, the mid time, the roof temperature is the highest. But for the hollow model, the south wall is highest because of the solar evaluation is less than 45 degree in December. And we also compared the daily wall temperature and the different heights and the orientation. And we found the wall orientation and the wall and the solar evaluation are important factor to decide the distribution of wall temperature in the wall. Yeah. So we can see both models have a significant vertical gradient change. And we also compared water model and the hollow model for the heat storage. And we know that building heat uh, capacity affect the heat storage. And the water model have a higher building storage capacity, which is about twice of that of hollow models. And we also showed this is 2D street canyon results, and we found the two important influencing factor, that is weather condition and aspect ratio. And you can see in deep canyon has a more profound change in vertical gradient. And we also compared the air temperature inside the building and outside the building, and we got this result. And indoor air temperature in both canyons shows significant vertical temperature grade. Mm. But in deep canyon, the air the indoor air temperature is higher, but the outdoor air temperature is lower for deep canyon. We compared the daily radiation and albedo under different sky condition, and show that the sky condition play important roles in surface energy balance model, and also show under the clear days albedo was slightly higher on the clear day than on the cloudy day. We compared the heat storage in different urban units. We can know that the White Canyon show a dominant contribution from the ground heat storage because the canyon is wide, and the Deep Canyon shows a similar contribution from ground and walls and the roof. We also gave them a daily cycle of surface energy balance. And finally, we compared, as we know, there is a hysteresis between the heat storage and the net radiation. And we also call it a lag effect of these two terms. And we know that it's quite different on the different sky condition and the different aspect ratio. So the result is the dependence of heat storage on net radiation is stronger on clear day than on cloudy days. And the second result is there is stronger lag effect in wide canyon compared to deep canyon. Let me simply summarize the conclusion. That is, our skate outdoor experiment had some advantages. It has good controllability and can reduce uncertainty of urban surface energy balance. And we got some basic physical character about urban energy balance. and thumb temperatures. And in the future, we will consider more surface color and more material, and we will also consider some vegetation. Actually, some of this research is ongoing, and we will use it to evaluate some urban canopy model, or can evaluate CFD results. And this two paper is related to this presentation. Uh, and actually, this scale outdoor platform is established by Professor Jian. So if you want to have collaboration with him, or you want to evaluate your models, use this platform, you can send email for him directly. Thank you for your attention.